Hey everybody, Dr. Rachel Valletta, environmental scientist with the Franklin Institute, here to bring you another Facebook Live. Today's theme, we're going to be leaning into science denial, getting an understanding a little bit of what it is and importantly how you can combat it. Now, we're bringing this story to you, of course, because it's coming on the heels, rather, of a pretty contentious political time when a lot of science denial has been at play. And interestingly, we're seeing a lot of the same tactics employed in the political realm, in the political sphere, as we are in more traditional science denial cases. And so we're going to talk today about what some of those tactics are for you to sort of re-up on, so you're ready to identify and combat science denial. Excuse me. Today we'll be employing a framework that I like to use, and we've used it a couple times at the Franklin Institute, including here on our Facebook Lives, and that's the FLIC framework. Now the FLIC framework, let's give some context here, was actually developed by and for climate communicators and climate scientists that are no stranger to having to combat science denial, misinformation and disinformation campaigns. And we'll define the difference between those two things in just a moment. So again, even though this was defined and created for the climate realm and climate scientists, it can be applied to any science denial efforts. Now, those of us that have been watching science news might be thinking that this could be helpful to combat science denial when it comes to vaccines. And yes, you'd be absolutely correct. But it was developed based on decades of research into those tactics that are used to try to undermine trust in science and the truthfulness itself of scientific data, including whether or not HIV causes AIDS, including whether or not smoking tobacco is linked to lung cancer, and even flat earth theories, belief in evolution, belief in vaccines, belief in global warming and climate change. All of those topics can be advanced with scientific robustness using the FLIC technique. So we're going to get into that in just a moment. And so the FLIC technique was actually brought to us by researchers at the George Mason Center for Climate Change Communication. So I'm going to be relying on case studies pulled from climate science. So you won't just get the FLIC techniques today, you're also going to get a little bit of an insight into some of those storylines as they've popped up in the climate realm. You're going to see me leaning back and forth here between my slides. I'm just going to keep an eye on my question list coming from our back-end team. Thanks to those folks. And for those of you at home, if you have questions, go ahead, pop them into the chat, and they'll be shared with me. So first off, what is science denial? Intuitively, we all sort of have a sense for what that means. Yes, it means denying science, but more specifically, one definition that I like to use that I'm going to cite here is the employment of rhetorical arguments to give the appearance of legitimate debate where there is none. All right, let's break that down. The employment of rhetorical arguments. So that simply means offering a persuasive argument. And most insidiously, many times these rhetorical arguments are used to undermine the notion that scientific consensus exists, scientific consensus itself exists, or a fact that is supported by scientific consensus is accurate. So we want to be very, very careful, of course, for that effort being advanced. And sometimes this can be accidental, and that might be the case of misinformation, but I also drew that distinction before between mis and disinformation. And the difference between those is disinformation is a type of misinformation that is advanced purposefully with nefarious intent. We're going to see that as it pops up in climate examples. But when I say nefarious intent, of course that means an effort to confuse the public on a scientific truth or the existence of scientific consensus with really potentially negative outcomes. You can imagine what those outcomes might be if those efforts are successful as it pertains to climate change or vaccines. So that's why it's so dangerous, and that's why we want to be on the ready for it. Okay, so how can we spot science denial? Well, we're going to use the FLIC acronym here, and these are just the topmost levels of science denial tactics, but in fact there's an entire taxonomy and broken out subsections of each of these that you can check out on the Science Denial 101 course. We've got a link that we can share in our chat for that. So first and foremost, we want to be on the lookout for F, and F stands for fake experts. I'm sure a few of us have in our personal lives come across fake experts. These, of course, are folks that are propped up as reputable sources of information, or institutions that are propped up as reputable sources of information, when in fact they might not be. So let's take a case study from climate science. This is a couple decades old now, but it really stands as a good example of how fake experts are trotted out as real, legitimate climate scientists, excuse me. And this comes from something called the Global Warming Petition Project. You may have heard about this. Again, it's about 2 decades old now. It stems from a science institution in the state of Oregon, and it is a proposition that looks to experts to sign on, which says that global warming isn't real, it's not caused by humans, it's not happening, it's totally debunked. They've got about 30,000 or so experts remember, that have signed on to this global warming petition project. But if we go to a simple layer, the next simplest layer of analysis, and ask who are these experts, well, it turns out that the bulk of these signatories, these experts, about 99% of them, although many of them have higher level degrees such as PhDs, many of them don't have any expertise whatsoever in the field of climate science. So even though the Global Warming Petition Project has 30,000 or so signatories, very few of those folks have any understanding whatsoever of climate data and how the climate system on our Earth here works. And so, of course, that's an example of when we trot out a bulk number of fake experts. 30,000 sounds like a whole heck of a lot, and indeed it is a significant portion, or a non-negligible rather, percentage of folks that graduate from universities in the United States every year. But these folks are not graduating with expertise in climate science, at least those signatories to the Global Warming Petition Project are not. Okay, so we want to be ready, on our toes, looking out for fake experts. Someone asked me, you can spin anything. Yes, you can spin anything, and strong rhetorical skill sets and strong communication skill sets can be used for good or for evil, right? And that's maybe where that disinformation effort comes in. So yeah, you can spin just about anything. But you, the public, our wonderful TFI audience out there, knows to be on your toes, to be ready to understand when spin is happening. And certainly fake experts attempt to spin just about anything. Okay, so that is F in our FLIC framework. Let's move to the next one here, and this topic is logical fallacies. And this one's kind of a mouthful, but we'll walk it through using, as I said, a climate example. So logical fallacies. These are simply arguments where the conclusion doesn't necessarily follow from the premise of the claim. So let's look to a common logical fallacy that is advanced in the climate world, the climate sphere. And that is that climate change has happened in the past, and so climate change that's happening now must be natural. All right, let's break that down. What's the premise of that claim there? That climate change has happened in the past. And the conclusion of that claim is that, so climate change that's happening today must be natural, ergo not human caused. All right? We can very easily show that that conclusion doesn't actually stem logically from the premise of that statement. And I'm going to draw a quick graph here for you to help understand that. So I'm going to have to erase what I've just written. Remember, we're talking about logical fallacies, L, in our FLIC framework here. Let's consider that claim. Climate change has happened in the past, and so climate change happening today must be natural. Well, we can use a carbon dioxide data set to very, very easily undermine that claim. So let's draw what carbon dioxide concentrations look like over time. Now we're going to draw carbon dioxide concentrations because, as you folks at home know, carbon dioxide is the driving force behind why temperatures are increasing at the Earth's surface today. And we know that the vast majority of that carbon dioxide is coming from human sources. Alrighty? So on our plot here, we're going to put carbon dioxide on my y-axis, which indicates, of course, that in the vertical direction, carbon dioxide concentrations are increasing. And on my x-axis, I'm going to put time. And I'm not going to write out individual numbers here. You won't be able to see them on the camera resolution, but we're talking about hundreds of thousands of years here, okay? Hundreds of thousands of years. Over the past 800,000 or so years, we can see that carbon dioxide concentrations naturally, again, this is pre-human time, naturally fluctuate, and they look something like this. There's a lot of squiggly lines, but roughly they do this, right? They go up and down with a periodicity of about 100,000 years. So we see that naturally carbon dioxide concentrations have been very high in the past. They've also been very low in the past. And then again, they raise and they decrease. And this actually corresponds to when we have ice ages on the Earth's surface. So when carbon dioxide concentrations are higher, of course, temperature is higher. And when they're lower, of course, temperature is lower. So this is what the natural variability, natural climate change, if you like, looks like over geologic time without any human influence on it. But let's look at what carbon dioxide concentrations comparatively are today when we draw them on this plot. And they look something like this, okay? Now, this depiction of carbon dioxide concentrations looks nearly vertical, right? Of course, we could zoom in the resolution on a smaller period of time on the end of the graph here, and we would see a different shaped trend. It wouldn't look so vertical. But when we're comparing it to long periods of time, this is roughly what CO2 does after humans come around and start burning fossil fuels, carbon dioxide emitting fossil fuels, of course. Okay, so if we know that climate change is happening today, then, in the context of human behaviors, and we know that carbon dioxide is probably the engine driving that, we can very, very easily from this plot compare climate change happening today to climate change that has happened in the past. And I'll simply put the question to you folks out there. Do you think that this trend on the rightmost portion of the graph looks like the trend on the left portion of the graph, where we see natural variability and we see human-influenced behavior? It's not so difficult to surmise from this data set that the climate change happening today is probably different in character than in the past. So let's go back to that original claim that we mentioned, that logical fallacy, that climate change has happened in the past, so climate change happening today must be natural. Does that final conclusion from that statement make sense to you? Do you think that climate change can possibly be natural today compared to that historical, or rather geologic record? I think not. All right, so that's a logical fallacy. More broadly then, logical fallacies, there are a slew of ways to go about trying to confuse folks on scientific data. You can misrepresent data, you can overinflate the importance of data, and you can also attempt to purposefully create ambiguity around data. These are all techniques used when it comes to logical fallacies. Okay. As we're transitioning here, remember you can ask questions in our Q&A and they'll get passed along to me on this side. So remember, we're going through the FLIC framework here. The FLIC framework is helping us identify science denial techniques. And we've just moved on to I. I stands for impossible expectations. Impossible expectations. And impossible expectations is a little bit self-defining, right? It's this idea that you can set unreasonable or scientifically meaningless expectations to scientific data. Let's take a common example from the climate science and climate communication space. You may have heard this claim made, and indeed it's been made in the highest levels of international governance. And it's this idea that if it's cold outside, global warming can't possibly be happening. It's cold outside today here in Philadelphia. I woke up, it was about 27 degrees. That's pretty chilly, right? That's pretty chilly. But does a single day of cold weather negate the entire reality of global warming? Which tells us that over time, we're seeing temperatures increase at about 0.15 or so Celsius per year. No, of course. And why not? This all has to do with the difference between weather and climate. And I'm going to write that down, okay? Weather versus climate. Now, if you've been on one of my Facebook Lives before, particularly when we've featured meteorologists in the past, I'm always hollering about weather versus climate. Now, weather versus climate is an important and very simple idea to clarify for yourself, to be ready to defend against impossible expectations when it comes to climate change. Weather, of course, are those day-to-day temperature and precipitation fluctuations. We feel them on the short term, throughout days, throughout weeks. Climate, comparatively, are those long-term trends. In fact, we need 30 consecutive years of weather data to make up a climate trend. We know that within a long trend, we can have short fluctuations. And often, what folks that are attempting to instill confusion around the existence and the reality of global warming attempt to do is they attempt to look at just portions of the record, and they attempt to conflate that noise with the overall signal to suggest that a larger phenomenon isn't occurring because there's been a singular aberration. And this one ties very, very closely to our next letter in the framework. And that's the next C, and that's cherry picking. So we'll get to that in just a moment. But remember that original claim that I brought up, that it's cold today, so global warming must not possibly be happening. This is an example of an impossible expectation. We're setting the expectation that global warming means that we're never going to have cold days again. That's not the case, and that's indeed not what climate scientists are saying. What climate scientists are saying is that as global warming proceeds, there's a higher likelihood we're going to have warm days, and a lesser likelihood we're going to have those extreme cold days. Okay? So that's setting an impossible expectation. So we do have a question as it relates to weather and climate. And the question is, don't weather and climate influence one another? It's an excellent question. And indeed, insofar as climate records are informed by long-term weather patterns, yes, absolutely, they're intimately tied. These records are built on the same data points. And indeed, as we see long-term trends and long-term behaviors in our climate system start to change, we might see individual weather patterns start to fluctuate. So let's consider, for example, the La Nina-El Nino cycle. We won't get into the nitty-gritty here, but essentially this characterizes roughly every few years we see anomalously high temperatures in the eastern Pacific off of the west coast of South America. And this impacts us here in the United States because we see our hurricane season changed. So sometimes when we have those temperature fluctuations in the southeastern Pacific, we can actually see that hurricane seasons in the southeastern United States are either more active or less active. And there's an example of where a feature of our climate system, the El Nino-La Nina cycle, could be starting to change fundamentally, which can then impact a singular weather event, making a hurricane, for example, stronger or weaker in a given season, depending on how that climate system is behaving. So yes, absolutely, there's an example of where the reverse happens, where a climate phenomenon can actually impact the likelihood or the intensity of an individual weather event. So to that question, don't weather and climate influence each other? Yes, of course, intimately they do. Okay, but we should also say that in the original claim that if we have an individual cold day, that global warming isn't happening, that is, again, setting an impossible expectation. That in that very specific case, just because global warming is happening and scientists are characterizing global warming as happening, they're not saying that we can't have cold days still. What they are saying instead is that it's less likely. Alrighty, so that one got a little bit complex. We got into some nitty-gritty climate phenom there, but we can, of course, apply the notion of impossible expectations to other science topics. Okay? Alrighty. So let's move on then in our framework here to the first C, and that C is cherry picking. Now, cherry picking is an effort to essentially selectively highlight data from larger data sets and take it out of context to prove a particular point. Now, we see this often at play. Remember, we talked about vaccines at the beginning in the session today. Sometimes we point to individual cases within a recent trial, for example, a recent vaccine trial, which was halted following the impact of someone getting sick after they got their vaccine shot. Turns out that they were an outlier, and the vaccine testing moved on after that. But that was cherry picking. It was pointing out one individual case within a larger slew of cases. And that was pointed to make the claim that all of the vaccines are useless and all of the vaccines are dangerous, which of course is not the case. If you want a thorough understanding of that, check out, of course, all of our live videos with our chief bioscientist, Dr. Jayatri Das. We've also seen cherry picking happening in the climate data realm as well. And this is a really common tactic that's been employed, although we're seeing it less frequently as public consensus around climate change starts to come around. So what's a common cherry picking effort that we've seen in the climate realm? Well, let's refer back to that example of weather and climate. Now, an entire climate record might look something like this. Let's look at temperature. I'm going to draw this plot here, temperature on the y-axis, higher temperatures, again, up in the vertical direction. And over time, again, time progressing in the right direction of my x-axis here. Temperature records over time, annual average temperature records look something like this. There's a lot of noise, they change shape, right? They might do something like this. Alrighty? There's a lot of fluctuation in there. Now, if we were to look at the overall record of temperatures in this kind of messy plot here, what would we see? Well, we might draw a trend line. Let me change colors here. We're going to look at red here. If we look at the overall trend line, we might surmise this. That on average, it looks like temperatures are increasing over time. And indeed, if we were to use the proper statistical technique, we would find that. But sometimes what happens is cherry pickers come along and they take just a small portion of the data and they claim that that means that the overall trend isn't happening at all. So what might that look like? I'm going to erase this. I'm going to draw that again. And we're going to cherry pick some of that data. All right, I'll try to reenact what I did before. I don't know how successful I'll be, but let's imagine our data set looks something like this. Remember, the overall warming trend is up over time. But if I were to cherry pick, if I were to look at, let's just say, the first 10 data points, what would my temperature trend be? Well, if I look at just this first portion of the graph, the trend line among that might look kind of flat, right? Or what if I cherry pick another portion of the plot? Might look something like that, right? I can actually find those negative trends in a number of areas, right? If I cherry pick the data. And we've seen this happen a number of times to suggest that either temperatures aren't warming, as we've shown in this example here, they're flat over time, or to actually say that temperatures are cooling over time, where we can make that conclusion based on a cherry-picked portion of the data, a subset of the data set, taken out of context. We can suggest that temperatures are actually decreasing over time. We know that's not the case. We have to take the entire data set within context and into consideration. So we want to be very wary of folks that are cherry-picking data, just pointing to one or two aberrations, as in the vaccine example that I mentioned, or subsets of data sets, as in the temperature record that I'm showing here. Okay, so it looks like we've got another kind of a lengthy question, so let me peek over at that before we move on to our final question. So this has to do with climate change. It's been happening for billions of years. Our planet constantly changes and the life on it adapts or perishes. What did the dinosaurs do to deserve a meteorite shower? Well, the dinosaurs, of course, didn't do anything to deserve a meteorite shower. That was an unfortunate, although statistically possible, event that happened within our universe, a bolide impact. Okay, so I think we'll probably move on from that then. All right, great. So we've got one last C in our framework here, and this is particularly important and prescient and timely for the time we find ourselves in now. And the final C in the Flick framework stands for conspiracy theories. Conspiracy theories. Now again, this is a really, really powerful tool that science denialists use to instill doubt among scientific truths and among scientific consensus, or to try and instill doubt around the fact that scientific consensus exists, rather. Now, this is proposing that some sort of a secret plan exists, right, to implement some sort of nefarious scheme to hide the truth. Really, really broadly in the climate science world, we know that folks have tried to say that climate scientists want to advance the reality of global warming, wants to advance the reality of climate change, simply because they're going to gain politically or financially from that somehow, which is an absolute ludicrous argument. Any of those of us out there that are scientists know that this is not necessarily a lucrative business we find ourselves in. That's kind of silly from the baseline. But we have seen that many of the folks that are lobbing these conspiracy theories, ironically, are those that are actually gaining politically or financially from advancing conspiracy theories. We've seen this happen a number of times. This is well documented. I encourage you to check out both work by Naomi Oreskes. She's a Harvard science historian. An excellent text here is Merchants of Doubt. You've heard me recommend it before, but check that out if you want to learn more about how folks have actually benefited from advancing conspiracy theories, that scientists are benefiting from advancing conspiracy theories. So a little bit circular there. But of course, common conspiracy theories surrounding climate change are that global warming isn't actually happening, that climate scientists have some sort of master plan to take over the global governance system by claiming that climate change is happening. Of course, all of these conspiracy theories are just that. They are conspiratorial, and they are easily debunked. But I do want to flag that dealing with conspiracy theories and attempting to overturn the sentiment that they exist can be challenging, and sometimes, as we've seen in the political realm, can be somewhat dangerous. So how can we go about dealing with conspiracy theories and more broadly addressing science denial? Well, first and foremost, we want to identify science denial. We can use our FLICK acronym here. Remember, if there are fake experts, if there's logical fallacies, if there are impossible expectations being set, if data sets have been cherry-picked, if we're seeing some outstanding examples being overinflated, you're going to want to flag that. And of course, C, if there is a conspiracy theory. Now, sometimes these are difficult to detect, and sometimes they're not. But baseline, if a claim is made that you think is curious, check it out. It's as simple as that. So some basic social media and news literacy skills that we all want to remind ourselves are, of course, we always want to check out, we want to scrutinize those claims. We always want to check out the resources that are being cited to support these conspiratorial claims or any kind of science denial claim. We always want to check out, of course, the sources of the information itself. And you can ask yourself these common questions to help identify that. Do you recognize the organization or the individual that's advancing these claims? Does the information seem baseline believable to you? Is the post written in a style, if it's a social media post, written in a style that you might expect from a professional and reputable individual or institution? Do you think that it's politically motivated? Of course, we want to be on our toes there, especially when it comes to those disinformation efforts. And I'll finally end on the notion that we should remember that belief in especially conspiracy theories, but science denial more broadly, often has to do with who we are ideologically as opposed to our scientific literacy. Now, it is true that in some cases, we can see that scientific information can actually be effective at combating science denial. But most often it has to do much more, again, with who we are as people and our identities. So if we want to overturn science denial, instead of offering scientific facts to combat scientific denial, we might actually want to try a different route and try having a conversation instead. We talk a lot about this here at the Franklin Institute, and we hope that we model that for you folks. But of course, you can always engage with us and ask any kind of questions about how to go about doing that. When it comes to particularly politically contentious and politicized issues such as vaccines, such as the topic of climate change, try holding a conversation based on shared values instead. If you've got someone in your family that is want to believe in conspiracy theories, try talking about understanding why they believe in that. Try connecting on the fact that you share common bonds, you share common relationships, you share a lot of common interests, probably more common interests than not, and exploring why they believe in a particular science denial claim or conspiracy theory. Excuse me. Yes, getting a little dry here, so we're coming up on the end. So we'll hit pause, but I'll just say that when entering into those conversations, you want to make sure that you're creating that trusting space, that you're asking these questions and truly listening. That's hard for us to do nowadays, I know, but truly listening and valuing that input, and also coming in with no avarice. Assume best intentions. Just because someone believes in a conspiracy theory doesn't necessarily mean that they can't be pulled away from that. However, if it is someone that is unfamiliar to you, maybe you're not the right trusted messenger in that space. So always be asking yourself too, am I the right person to enter into this conversation? Okay, so we went through a whole heck of a lot of information there. It looks like our questions have paused. We're coming up on about a half hour, so I'm gonna stop us there. Remember, you can use the FLIC framework to help understand when science denial is happening, to call it out, and use some of those tactics that we talked about to really try and diffuse that information. If you have ongoing questions, go ahead and share them out with us. If you like this kind of content, if you want to learn more, you can check out the Science Denial 101 free course. I shared a link with my team here. I'll ask them to drop it into the chat. You can learn all about many more claims that have to do specifically with climate science, but again, can be applied to combating science denial in a number of topical areas. So that does it for me today. Remember, I'm Dr. Rachel Dawn, your environmental scientist at the Franklin Institute, and I really look forward to our next conversation together. Till then.